Thanks everyone to KubeCon, and thanks everyone for joining today's session. Today we're going to give you a comprehensive analysis on the popular schedulers in the market, which are Kueue, Volcano, and the YuniKorn, which are the most asked question among the audience we interact with. Before that, let's introduce ourselves. My name is Wei Huang. I'm the co-chair and the maintainer of SIG scheduling, and I work for Apple AML.
Hello, my name is Shiming Zhang. Work for DaoCloud in Shanghai, and I'm the SIG node reviewer and the SIG scheduling sub-project Quota maintainer.
All right. Today we are going to firstly give you a high-level overview on the schedulers, what's their history and the relation with Kubernetes default scheduler. And next, going deep dive on the features to help you better choose which scheduler may best fit your workloads. And lastly, give you some guidance and best practice on benchmark some particular feature of the scheduler. So firstly, I think the question may be asked is that why there are so many schedulers? Or what's missing in the kube scheduler to serve like batch workloads? So in my eyes, there are three pieces that may be missing in the default scheduler as well as the native Kubernetes. One thing is, for a long time, kube scheduler is originally designed for service workloads. That means each pod is treated as an individual unit to do the scheduling cycle. That has a good size, which can be consistent to accommodate the pod whole life cycle and to have the unified integration with other components. And all the APIs are imposed in the pod level. But the downside is that we didn't give the job level scheduling constraint more attention, which caused some decision that make for a single pod may not be necessarily optimal for a whole job, for example, GAN scheduling. The second piece is that the native Kubernetes doesn't offer a good notion to maximize your cluster's capacities. It only provides a static notion called resource quota, and that is associated with the namespace. But in the modernized organization, they may want like a shareable quota and maybe even has hierarchical in that to manage those kind of quota. The third thing is the internal implementation of the scheduler is a one queue setup. Just like the Excel London, the hallways, one queue. So, but in terms of some advanced feature that is batch workloads needs, it's better to design them in a multi-queue design so that some features can be more design implemented in a more natural way. So this is the three pieces I think the kube scheduler is missing. So a glimpse at the history, kube scheduler was raised along with the Kubernetes 1.0 at 2015. And then an experimental sub-project of SIG scheduling called kube batch was raised in 2017. It was original design. Its initial intent is put it as a side project so that it can involve the batch-related capability at its own pace. And finally merged with kube scheduler. But due to some reasons, it didn't go as planned, because by that time, the focus of SIG scheduling was more focused on expose the scheduler extensibility as a framework, which is called scheduling framework, so that the project Volcano comes into place. You may be notice that the first version of Volcano scheduler was forked, from the kube batch. And Volcano was later donated to CNCF. And YuniKorn, later in that year, 2019, was raised. It leveraged a lot of design concept of the Yarn scheduler, and also is hosting the Apache Foundation. In 2022, Kueue was raised to resolve that is, in terms of the job scheduling side, there's the missing piece in the whole native Kubernetes ecosystem. And it's a sub-project of SIG scheduling. I think before we dive into the features, we should get a high-level understanding about the workflow when using these schedulers. For default scheduler, maybe you are already familiar, is that you submit a job or job-like workloads. The workloads controller will be responsible to fan out the job to pass, and the path gets scheduled by the default scheduler. For YuniKorn, it's basically the same way. It's just you have to associate particular YuniKorn specified label and annotation to describe the characteristic of the job or application so that YuniKorn can optimize for that job. So that is YuniKorn's design philosophy. For KQ, it's different because in the picture you can see that the workload controller is not allowed to immediately create paths. It has to wait for KQ to admit the job. So that is the key thing KQ do, is that according to its queue setup, its own API design, once the job's in queues, it will do some checks, fairness check, quota check, some extensible checks, and then when that check has, all the checks has passed, it will ungate the job so that the job controller can create the path, and the path gets scheduled by default scheduler. For YuniKorn, in basic, the same pattern as KQ combined with default scheduler. But the little difference is Volcano has its own API called the VC job as well as part group. And those API carries, Volcano its own API characteristics so that it has to be honored by its own scheduler. So usually the Volcano controller and the Volcano scheduler are combined together to be used. If we put all the scheduler into the scheduler spectrum, and I think use the mission as a boundary can best help you understand where they sit. So Kube scheduler definitely sits in the path scheduler side, as well as YuniKorn. For KQ, it's more doing the jobs at the mission and doing the job level management, the queuing thing. For Volcano, they land on both sides, controller and scheduler, and they have to be used all together. So this is basically the overview. Next, we will dive deep into the features. So as I said, default scheduler has only one jumbo queue, which doesn't fit the batch workloads requirements. So all these three schedulers adopt the same pattern, is that it has multi-queue, and the multi-queue are divided into a tree-like structure. So the user can only submit the job to the leaf node here in a tree-like structure. Among the features comparison, I would say I would recommend use the API as a distinguisher to look at their designs. For example, I think KQ has the most Kubernetes native API design for you to use them out of the box. And also it has the API directory for you to control which user can submit job to which queue, and also associate with the Kubernetes term like RBAC, like namespace. So basically, I think that its APIs can be used out of box in a self-service way. Other two may have some shortcomings, like for Volcano, it doesn't give you a notion to control which users can submit job to which queue, although it's used a QCRD design. For Volcano, so for YuniKorn, it's embedded every configuration into a jumbo config map, which is not that Kubernetes native, because if you have only one single configuration, that means it's not easy to use that for multi-tenancy thing. You have to introduce another layer to do for self-service for multi-tenants. So based on the hierarchical multi-queues, each queue can be associated with Quota. And again, these three schedulers adopt the same pattern to offer min-max quota management, which can also be interpreted as guaranteed quota versus best efforts. In this case, suppose organization N has 4 CPU, it can divide statically or can be dynamically. It says, okay, team X maybe can burst their usage to all 4 CPUs. And then if we go down, that is, all the CPU might be consumed by team X2. But for the cases that is the best efforts tenants use all the resources, it can be reclaimed by the others if other tenants' guaranteed resource is not satisfied. This so will yield the preemption. So for the queue-based features, I would say they are mostly the same in terms of functionality. It's just that the APIs are designed a little differently. 2 things to call out here is in terms of preemption, YuniKorn only supports the inter-queue preemption. That means one workload can only preempt the workloads in another queue instead of the same queue. And also KQ preempts using the job as a unit, but the other 2 can preempt using pod as a minimum unit. Next, we are going to talk about Gantt scheduling because it's a pretty essential features in terms of batch scheduling. Basically, it means you want to schedule all the pods together or nothing. Let's look at YuniKorn first. So YuniKorn doesn't involve job CRD, so it basically waits for the pods to be created. In this case, 4 pods here, and they carry the YuniKorn-specific Gantt scheduling annotation or labels. And then once them in queue, interesting here is that in YuniKorn's design, it creates the same number of placeholder paths and try to schedule the placeholder paths. If they can be scheduled, the placeholder paths will be deleted and then replaced with the real paths. So this design, you can see that it will increase at least the API requests because it's almost triple the API requests. The placeholder, you have to create them and delete them. Also, there can be cause some risk condition because this is just in different steps, replace. For Volcano, it's scheduled paths the dry run in memory manner. So once a job in queues, once it's passed some basic checks like quota check, it will be found to pass, and the pass will do the dry run in memory. Once they can be scheduled all together, it will be scheduled. That is basically how Volcano does. For KQ, it doesn't involve pod scheduling. It leverages other schedulers' pod scheduling capabilities. So once the jobs in queue, once it's passed some basic quota check, it will just create the pods, let the pods be created and be tried to be scheduled. So definitely, in some cases, it's possible that not all the pods can be scheduled together. So it has a feature called wait for pods ready to be a last resort, to be based on the timeout to delete the job and retry. So this mechanism is not that ideal. That is why you see in some community like Kubeflow, they use KQ plus a particular code scheduling plugin to retrieve better accuracy of the Gantt scheduling. So next part is how these schedulers cooperate with the ecosystem. Like the first part is computing framework. Definitely, we are not able to analyze every computing framework here. But I'm going to try to summarize a common pattern. Suppose we have a new computing framework called Foo. Usually it comes out with full CRD and then has a full operator, which is responsible to interpret the CR objects into paths. So by default, it doesn't rely on any particular scheduler, so default scheduler can go schedule them. So usually the batch workloads has a coordinator part and some worker part. For Volcano and YuniKorn, The integration they usually do is that they change the source code of the full operator to let the full operator create the paths or particular the schedule-specific API carrying the required information. For example, for Volcano, it creates a part group to carry in the corresponding information. For YuniKorn, is because it doesn't have the job API, so it just imports the queue information, etc., to the pod level, and then hand over to their corresponding scheduler to schedule them. You can see that it's a little invasive to the full operator because every time you have to change your source code once a new computing framework comes into place. But for KQ, it's a little different. Is that it's leverage a generic suspension pattern, which basically is a round-trip communication. Okay, the first one is tell that it's okay, suspend first. I will handle the admission of the job. And then once I think it's ready to be scheduled, I will let you know. And then hand over to you to schedule to create the pod for the downstream scheduler to schedule them. So this is the biggest difference with the other. I would say the suspension mechanism is a key concept in KQ. It can be easily adapted to some new framework in a sustainable way because you don't have to change at least don't need to change source code too much in the computer framework in the market. The next thing is think about cluster autoscaler. CA is much more important in the modernized cloud infra setup because of like cluster utilization, cluster cost. So first, I think we should understand how CA simulate the unscheduled path scheduling. So the fact is that CA use the default schedulers SDK to do the scheduler simulation. In other words, whether the scheduler you choose are compatible with the kubescheduler SDK really matters. For example, like take DRA as an example, which is introduced in 132. And by the time I prepared the slides, YuniKorn and Volcano doesn't support that yet. But for KQ, because it's not a pod scheduler, it's leveraged on default scheduler. So basically it supports DRA. The other thing is that look at CA in another early intervene way. In most cases, we are just passively waiting for the unscheduled pod to be picked up by the CA. But if we think one step further, whether or not we can intervene, how to interact with the cluster scaler to reserve some resources once the scheduler sees some unscheduled pod, instead of wait for CA to intervene. So that is some API called provision request raised by the SIG autoscaling group. So that is only supported by KQ so far. There are some other areas we should think, I think, for multi-cluster, multi-queue, KQ support that in a native way. For Volcano, it leverages Quota to support the multi-cluster. There are definitely some other considerations because of the time limit. I cannot go through all of them, like extensibility, support, debuggability, etc., etc. So next, I will hand over to Shiming.
Okay, next part, let me compare the performance of the simple feature. Let's see how the difference between the features. Before we start, I want to highlight the default setting that's different between the schedule and the grid efficacy resource. The default schedule uses the API QPS, which is 50, and the Unicode default QPS is 1000. The definitely not apple to apple. You will see the result definitely low. So back in our testing, we try to best to make a list of the QPS, the same between the schedule and the controller, as well as some other settings ensure the all result. The next thing is that we have made some innovation in the way we collect the metrics and do performance comparison. The traditionally way is use Prometheus metrics, but if you use Prometheus metrics in skill testing, for example, scheduling 10,000 pod, there are very high chance of the magging of error. The metrics themselves under the hood of approximator estimator when you're scheduling over a short period of time. All innovation here is to use API server audit log. Basically, the API server audit log each canned event exactly when a pod is scheduled and date, etc. All innovation is to collect all the event and use simple parser to check when a pod created data and then aggregate them. We plot them on the same Grafana dashboard, so you can see that we start them at the same data point and then over time how the key event of pod scheduling and pod deletion happen. So those two things I want to highlight before we dive into the performance result. Next is the performance environment. We use Kubernetes 1.32 for sense scheduling plus controller combination. For example, KQ we use 0.10 version. We are using upstream cost scheduling plugin and apply local patch fix a bug. We also found some bug to Volcano and the Volcano team provide a fix. Thanks for Zhang for helping us to fix them. Since Volcano has a button, schedule, and controller, we use the same version here. We have ensured the QBS the same for all controller and the schedules. For the benchmark testing, we use Kueue to simulate a node, which basically is the most powerful benchmarking tool on the market. At the highlight, we use two categories with GAN scheduling disable and GAN scheduling enable. We try to schedule 10,000 pods in total. The variable here is number of job and the number of pod per job. One extreme that is only one job with 10,000 pod. The other extreme is that we submit 10,000 job, but each pod we have only one pod. We didn't have vary the number of queue because in all local testing we didn't see a significant performance difference by the vary in the number of queue. So we simply the testing to focus on the number of job and the number of pod. The first case is submit many job with one pod each. There are two lines here. The dotted line shows the pod creation time. The solid line shows the pod scheduling time. You can see YuniKorn is ahead of the other two, but that's in because the pod creation time is ahead. I think it is related to the limit of the webhook QBS for the job, but we haven't found a way to adjust the webhook QBS for KQ and Volcano. If you look at the time difference between the pod creation and the scheduling, you will see they are pretty similar. When we change the number of jobs from 10,000 to 500, you can see the difference. Volcano needs to make more webhook requests to mutate the pod. Interestingly, the Volcano create pod in batch. I'm not sure if this is intentional design. If we reduce the number of job to 20, each with 500 pods. You can see the KQ is already ahead of the YuniKorn and the Volcano. And the Volcano is still behind. The last case is one job with 10,000 pods. Here, KQ and the YuniKorn is ahead, Volcano still behind. This is because there's only one job, so only one job webhook commuted request is needed. Summarize the 4 cases without GAN scheduling. If you have a lot of job, the scheduling speed are more related to the number of job webhook commuted requests. For KQ and the YuniKorn, the difference lie in the cost the mutation request. This, if there only one mutation request, KQ is ahead of the YuniKorn. Volcano is behind the other 2 in all cases. Now let's look at the other cutted with GAN scheduling enabled. Again, this is a 10,000 job with 1 pod each. YuniKorn create double the number of the pod. It uses the placeholder pods. It will create a placeholder pod to reserve the resource and then replace them with a real pod. So placeholder data then it's actually real pod scheduled. Look at the pod scheduling time. Volcano is ahead of the other 2. This is because Volcano was originally designed for GAN scheduling. I will show all the chart to help us better understand the results. The other chart focuses on the job completion time. You can see that Volcano is ahead of the case. This is for 10,000 jobs with 1 pod each. If we reduce job to 500, you can see that YuniKorn is passing KQ, and the Volcano create pod in batch again, but Volcano is still way ahead. The job completion shows the same result. I will skip all the 2 cases because when we reduce job to 20 and 1, the result is basically the same. In terms of the GAN scheduling, if your project depends on a lot of volunteers, Volcano is way better than other 2. That pretty much is for today's benchmark testing. We know there are many more use cases and professional testing conventional that we can include. What we show here the features that all have. For some feature, you may want to compare how the scheduler behave and many job versus few job. You may also have very customized user scenarios. We provide the project to do those testing using audit log, which give more accurate results. We have open source the key tools to cater for those testing. Don't be stressed about the benchmark testing. You can basically just use make command. We will open source everything to the showcase how to do the benchmark testing, so you can change parameter and run it out of box. Let's okay. We will have a roadmap to make the tools more professional. I think that's a good asset for the KubeCon talks. And we welcome contributors to make the tools better. Please check out the GitHub repo. Okay, that's it for the performance. I will hand it back to Wei.
Yeah, I think, sorry, we use off of the time, and basically that's pretty much today's talk. And lastly, I will give a big applause to the different maintainers of the three schedulers, Wei Wei, Yuki, and Shuzhen. Yeah, thanks for them to provide some insights about preparing the slides. Yeah, thanks everyone. I'm not sure if I'm allowed to take a couple questions. Okay, okay. Yeah, there's a mic there, yeah.
Hello. Thanks for the talk. I wanted to ask if you would compare the non-gang scheduling with the kube scheduler. Can you maybe elaborate on it? Like, were all the schedulers better in these large scales, or is there some case where the regular kube scheduler is maybe comparable?
I don't think that is makes sense because default scheduler doesn't consider this a gang concept. Okay. For default scheduler, like I said, the Kubeflow community is using a code scheduling plugin, which is based on the default scheduler's SDK and the scheduling framework. So that is how they are using right now. If you just use default scheduler off the box, well, there will be an accuracy issue. Yeah.
Okay, thank you.
Yeah, if you have more questions, I will be out of the room for a while. Yeah, thank you everyone. Thanks everyone.